Okay, let's see. So sorry if I screwed up the schedule. My flight was delayed for 3 hours out of San Francisco. We had to plane and then deplane, and then we planed again. I didn't think I was going to make it. I was a half step out the point of no return security where I was going to head back home, and I called Naomi, and she magically moved the schedule around. So thanks for accommodating, Doug. Okay, so my name's Chad Arimura, and I work on the Java platform group. So currently I lead developer relations. My talk today is probably going to be a little bit different. It's a bit of a detour of what I've done for most of my career, but I'm merging two worlds together, and I think for good reason, so I'll talk about that in just a minute. You've probably seen this before. It's what says I work at Oracle. Basically says don't make buying decisions based off what I say today. A little bit about me. So I've been an entrepreneur startup guy for most of my career. I was formerly the co-founder and CEO of a company by the name of Iron.io. And at that company, we've been doing sort of serverless computing for a long time. So around 2009, 2010, we created a product called Simple Worker, which became Iron Worker. And we started calling it serverless around 2010, 11 timeframe. Here's a couple articles that we wrote, The Future of Software and Applications is Serverless. We thought it was like a really cool, just like a cool idea. We liked the idea of not having to think about infrastructure. And so we thought it was like this buzzy term. We had no idea that it was going to be this whole thing. And it's pretty cool to see that it's become this whole thing. Granted, it took a lot more than just us to make it a whole thing. But hopefully we sort of got people thinking about the idea for a while. So I joined Oracle. Our company got acquired in 2017, and then what I did is build out the serverless engineering group. And then from there, once I created that group, we started the FN project, which is open source functions as a service. It powers the downstream service Oracle Functions, which is based off the upstream open source code. And then once that was off the ground, I moved into a developer relations role and ultimately ended up over in the Java platform group. So I'm going to talk briefly about Java, and I'm going to pose a question to the audience. And hopefully this gets you thinking a little bit about what does Java mean to serverless? What does Java mean to cloud native? So first, what is Java? Well, it's a programming language, right? It's been around for almost a quarter of a century, 25 years. That's a pretty powerful concept. It's been around for a very long time. It consists of the specification that's managed by the JCP, the Java Community Process, and implementations. The leading implementation today is called OpenJDK, 100% open source, GPL v2 with ClassPass exception. Open source, you can commit to OpenJDK, you can become an author, you can check out the mailing list. Everything that happens in quote-unquote Java, including the Java virtual machine, happens inside of OpenJDK. And there's a reference implementation of OpenJDK. And then there's many other implementations as well. By a lot of accounts, Java is the #1 programming language in the world. I know that statistics are kind of what you make of them. You can sort of fiddle them to be whatever you want them to be. But the reality is that Java is being used by over 80% of the enterprise. There's 45 billion Java virtual machines in existence today. And it really is the #1 most widely used language in the world. The ecosystem is quite large. It might be pretty small to see, but Oracle is one. So Oracle acquired Sun in 2010, and it's one of the largest contributors to OpenJDK today. But there's a bunch of other companies, many of which are in this room today, that care very much about Java. If you look at the list, you've got Google, SAP, IBM, Intel, Red Hat, JetBrains, Amazon, ARM, Twitter, and for good reason. Just recently, Bruno Borges from Microsoft posted that they count very heavily on Java at Microsoft. In fact, just recently, they joined the OpenJDK project as official committers on the committer team. So Microsoft obviously finds Java quite important. Amazon has their own OpenJDK distribution called Amazon Corretto. At Devoxx Belgium, Apple talked about their usage of Java. And in fact, one of the quotes was, if you're using an Apple device today, you're hitting a JVM, which is a lot of people. Twitter uses a lot of Java. In fact, I think they're using Scala on top of the JVM. They're also using something called GraalVM to get faster performance, which I'll talk briefly about today. And then there's a famous quote from James Governor, who I think is somewhere at this conference, saying when web companies grow up, they become Java companies. And of course, let's not ignore the enterprise, which is using a ton of Java today. So I pose a question. If only 5% of functions that are written today are in Java, only 5%, according to the statistic put out by Serverless Inc. A year ago, only 5%. If 80 to 90% of the world is using Java and only 5% of functions are written in Java, and the trend is not going in the right direction, why is this? The question is, why is that? And I pose that it's an important question to ask because if 12 million plus developers know Java, if 80% of the enterprise is using it, if it is one of the largest ecosystems of the world with over 2 decades of history, and most companies become Java shops when they grow up, I think it's important that we talk about this, especially at a conference like this, where if once you leave this conference, you'd think there's some existential crisis with Go or Kotlin or TypeScript becoming the #1 language in the world, when the reality is quite different behind the scenes. And so that's part of what I want to talk about. And how do we fix it? How do we empower developers to be able to use skills that they know inside of your organizations to be able to write, to be able to take advantages of the power of the ecosystem and move serverless forward? Okay, you've seen a bunch of talks today, and you're going to see a bunch more, and you're going to see a bunch of definitions. So I'm going to skip the definitions, and I'm just going to put one slide up there, which, even with this definition, it's debatable. But I really think that serverless is about doing less. That's why less is in the name of serverless. You want to think about things less. You want to do less stuff. You want to spend more time on writing the code that matters to you and your organization. So that's the only slide I'm going to put up there. But the experience of using serverless, in fact, this should probably be called like the characteristics of a serverless workload, maybe is like kind of an alternative title to this. No servers to manage, pay as you go, et cetera, et cetera. You have fast startup time. Okay, of course, there are not all use cases where this is necessary, but I think generally acceptable fast startup time. Small footprint, meaning, like traditionally big monoliths were really big, and you don't just take that and turn it into a function or a serverless environment. It takes some work. And then fast time to value. And I'm going to spend most of my time at fast time to value, but I'm going to talk briefly about the other two. Now, the first one, it kind of comes with the platform, so I'm going to skip that. So let's start with fast startup. And let's talk a little bit about what Java is today in that area and what it can be going forward. So if you think about the JDK or the JVM has something called ergonomics. And ergonomics is essentially how things are tuned to a particular workload. If you think about what you want your workload to be, you want it to start extremely fast. You want there to be no latency whatsoever. You want the footprint to be very small, and you want the throughput to be really high. And that's the orange line at the top. But the Java virtual machine with 2 decades of experience is very, very, very good at optimizing workloads over time, long-running workloads for throughput. But you know what? A lot of the times, 20 years ago, the JVM was started maybe once every 6 months when you did a deployment. That's obviously not the case anymore. So the ergonomics of the JVM doesn't align with the characteristics of what serverless thinks about today. But out of the box, the JVM or the JDK was optimized for other types of characteristics. So I'm going to introduce a few things that are happening in the Java ecosystem that sort of tailor it more towards the way we think about serverless workloads. Class data sharing is something that was introduced in Java 5. And basically what that does is takes your class data and then turns that into metadata files, archived files, that can then be loaded up into memory very quickly. So it takes something that traditionally takes the JVM a while at startup, turns it into a format that the JVM can understand, so you get faster startup time. That's essentially what class data sharing is. And it's been around for a while, but it's this thing that there's some steps you have to take in order to utilize it. And you can see with CDS, we actually turned it on in Java 12 by default. So before that, it was like you either have it enabled or you don't. It's enabled by default starting in 12. And you can see the startup time shrinking. This is enabled by default on many of the platforms. I know Lambda has it enabled by default. I don't know if some of the other ones do. And then just to give you, I'm not going to go into detail here, but if you look at the versions of Java, the enhancements we've made to class data sharing, we've actually extended that to your application classes as well. So now you can take your application classes from your code, turn that into a format that's easily readable by memory, and then make that so every time, for example, a function starts, it doesn't have to load up a whole JVM and do this kind of whole bytecode mapping of class data to memory. And so that's all been happening for many versions now, and that will continue to get easier and out of the box. So that's one area to keep an eye on. Another project that's really exciting coming out of Oracle Labs called the Graal VM project. If you read Reddit or Hacker News, you're guaranteed to have seen something about Graal. Graal VM is a number of things. One of them is a JIT compiler, a just-in-time compiler that's written in Java that's part of the JDK today. Another piece of that is what was called Truffle, which is like a polyglot interpreter that can run any language on top of the JVM. So you could run Ruby, LLVM languages, or Node, et cetera, on top of the JVM, which is actually really powerful, part of which many organizations are using today. For example, if you have some R code and you have a bunch of Java JVMs, you can actually do inline R just alongside your Java code, which is pretty neat. And then the third piece of Graal VM is what's called native image or ahead-of-time compilation. And that's basically taking your Java application and compiling it, ahead of time into a native binary that doesn't need the JVM anymore, and that can start really, really fast. There's some drawbacks to that today, where things like reflection become very complicated, or invoke dynamic, or a bunch of other kind of behind-the-scenes things. They're very complicated to do with native image, but this is a very promising technology to keep an eye on. To show you the ergonomics of AOT, or ahead-of-time compilation, I showed you the ergonomics of JIT, which is just-in-time. You can see it's optimized for throughput. What AOT tries to do is optimize Java workloads for startup speed and latency, and low memory footprint. But throughput goes down. But presumably, you don't care quite as much about throughput because you're not optimizing a long workload. You're doing lots and lots of small functions, for example, maybe millions of them. And then just upgrading your Java development kit, your JDK, there's a ton, hundreds and hundreds of performance improvements in every version of Java that comes out. So if you look at Java 8 to 9 was actually a regression because of the modularity system. But from 9 to 13, you can see that it's almost halved the time that it takes to spin up a Java, in this case, I guess a Java function, you'd call it. And then, of course, the platform's going to do a bunch of stuff for you in terms of hot functions, et cetera. Cold start time is a big thing in the industry. But this is just part of what you get from upgrading your JDK. OK, so that covers fast startup. Let's go into small footprint. Your application code, this is really important because traditional Java applications are based off pretty heavy frameworks. For example, I don't want to pick on Spring because it's great, but it's pretty heavy. It's not intended to be kind of turned into a small function. But you want to use smaller dependencies. You want less code. But I'm going to skip that because that's up to you as a developer. Here are other things that we're thinking about from the Java platform group or other things that you think about in the industry. So in Java 9, by the way, we're on 13. And I'll talk a little bit about the history of Java at the end. Maybe I should have put that at the beginning. But in Java 9, a few years ago, which was released, there was something called the modularity system. And there was a lot of very great reasons for doing that outside of the scope of this talk. But this is what the SC modules look like today. Most applications aren't using all of these modules. The JDK itself is over 300 megs. So just to run a Java program, you needed the Java development kit, which included the JVM, which is over 300 megs. But your application may only use, may run a line of SQL, and it may use Java activation to do something kind of Java beanie. If you're using those two modules, then we have a tool called JDEPs, which will give you the dependencies of those. And then you can use something called JLink, which you can actually take all those dependencies together using JDEP, and then you could JLink them into your own custom runtime now, which brings the JDK down to 30 megs or less. And you can do even better than that, but this is sort of, for all intents and purposes, probably the smallest JDK you're going to get in Java 9 going forward. Again, a lot of this stuff may not apply to you if you're using Amazon Lambda, Google Cloud Functions, but if you're using containers, using FN project, using OpenFAS, which I think you heard from Alex, I think I saw him somewhere here talk earlier about OpenFAS and other stuff. If you're using container as the contract, those are some of the things you want to think about, the size of your JDK or the size of your container. So there's a lot of work to decrease the size of the JDK. OK, the JVM, there's some tactical things here. Most of this is about, again, containers. If you're using a containerized environment, you want to be a good citizen in a multi-tenant environment. Until recently, the JVM wasn't even very good at even adhering to the container contract. So things like heap size, GC region sizes, these are things that were not optimized for containers. Starting with 8, 9, and 10, moving forward, there's a lot of work going into Java to make it much more container friendly. In fact, until Java, I believe 8, or maybe 9, it didn't honor the CPU quota or CPU period. So if you tried to contain your application inside of a container and only use a certain number of procs, it had a hard time understanding that. It would sort of break out to all of the CPUs and would starve other containers that were running in a multi-tenant environment. Again, this applies to containers. I don't want to sit up here and debate whether containers are serverless or not. Sometimes they are, sometimes they aren't, whatever. But if you're using Docker or some other container system, this is pretty important to think about. And then here is a bunch of bugs in our bug tracker that most of them have been solved. 10 in version 10, 11, a couple of them are open, all about making Java more aware of the container space that it's running in. Very, very important stuff, all happening, and we're thinking a lot about this. Moving on to the operating system, the only other piece I'll talk about, again, pertains to containers, but there's a project called Project Portola. And if you haven't seen it, check it out. We're actively looking for members of the community who care about running Java on top of Alpine Linux. What Portola is a project to help to make Java work better with the muscle library, which is the libc implementation, which is very lightweight. That plus, I think, BusyBox is what Alpine is based off of. I don't really know kind of, how many people in the room are using Alpine? Yeah, okay, so it's still important. So this is, so I would be interested to hear from anybody in the audience who's possibly using Java or wants to run Java on Alpine. This is a project for you. Okay. I'm going to move on to fast time to value, because I think the other two things are important. Platforms are working on it. It's getting better. It will continue to get better. But I think faster time to value is one of the most important areas. And as a former developer myself, or sometimes developer myself, time to value is really important. In fact, the reason we built Simple Worker, which is now Iron Worker, is because we didn't want to deal with anything outside of the logic that we wanted to write. And so we really literally wanted to write a piece of code, and we wanted to hit an API, and we wanted that code to just run. And that's what bore out Iron Worker. In fact, the real story is that Iron Worker was not the first product that we launched at my former company. We had like 5 other products that we tried to bring to market before that, and we weren't really excited about any of them. This is before VCs and all that. But then we looked at what the most important piece of that entire infrastructure was. It was actually this Iron Worker piece that was running code behind the scenes. And so that's why we felt it was really important to bring out. And that's what enabled us to bring a bunch of products to market really quickly. There's really 3 components here that pertain to Java about fast time to market, or fast time to value. Simplicity, which I'll talk about, perception of modernity. So, typically when you say Java, you think enterprisey, slow, old, antiquated, not moving fast. These are some of the things that you hear, which is actually not true at all. I'll talk a little bit about that. And then the ecosystem. And those are the 3 things I think sort of help you get to value faster. Okay, so there's a desire for simplicity right now. In fact, I think there's a big desire for simplicity even at this conference itself. Just the other day, I opened up Hacker News, and of course the top hit was the value in Go's simplicity. That's neat. Go is simple. It's been around, a lot. It's got a much shorter lifetime than Java does, and they've done pretty good in keeping the language simple and to the point. And it was one of the top hits. And then if you scroll down a little bit to number 6, you get the configuration complexity curse. Complexity is a curse. Literally, the language that we use is inherent to complexity being a bad thing. And it really is. Complexity slows us down. That's why we desire simplicity. And Java is certainly not the first thing we turn to when we think about a simple language. But there's a whole bunch of things happening. And if you are a Java developer, take a look at some of the stuff. If you're a reformed, moved on from Java, come back and take a look at some of these things, because there's a whole bunch of work happening in the language to make it more simple, to help you write less code, make it easier to read, and less error-prone. Again, powerful language, not known for simplicity. I'm going to talk a little bit about Amber, Project Amber, which is basically right-sizing language ceremony, as we like to talk about on the Java team. So here's your typical four lines of Java. You've got you declare your variable, you define it, and then you have your expression, and then you say what you want to call on the right side of the expression, and you set the variable. As you can see here, a lot of Java is sort of redundant. And so local variable type inference is basically inferring the type of the variable from the right side of the expression, and we introduce something called the var keyword. And that might seem really simple. Other languages do this. It's very nice. There's a reason why Java takes a while to do things like this, because of course, 20 years of history, we spend a lot of, the language architects spend an enormous amount of time ensuring that Java code that you wrote 20 years ago still runs on the JVM today. That's one of the reasons that Java is so popular today, is that we care very much about compatibility over time. So introducing something like this is not a light project. But what this does is it not only makes, so you have to type 10 less characters or 20 less characters, but you actually turn the focus of the language onto the variable naming itself. So you can't name crappy variables. Now, we can't stop you, probably none of you do this, but a lot of developers are really bad at naming variables. What happens now is it makes your code really confusing to read. But by exposing the variable here, it brings it front and center, and now you can think about how you name your variables. So this is just something that's simple and powerful in and of itself. And if you think about some sort of buffered reader, input stream reader lines of Java, it sort of makes you as a college student looking at Java going, oh my gosh, I can't deal with this. So this is a great step in the right direction. Text blocks, another area, was just released, and actually preview, which is about to be released into GA. This is another kind of typical line of Java code where you have to have escapes, you have to have a bunch of sort of indubitably error-prone code to do something very, very simple, like show some retweets and likes in an HTML snippet. Text blocks actually changes that and makes it so that you have an escape character now, and you can put everything in between it. And we've added a couple methods to help you with that, where you can do .formatted, and it acts just like your typical Java string, where you can now do formatted and inject those variables into the %s above. So you can see there's a lot less chance for forgetting a quote, forgetting a plus, forgetting to put the semicolon at the end, whatever. Now we've got something much more simple and straightforward, and it's actually very powerful. Switch expressions. When you look at the language designers for Java looked across the board and said, it looks like most people who are writing switch statements actually want to write switch expressions. And so most switch statements did something like this. You have a variable at the top, you have a bunch of cases where you set it, you break from each of those, and at the end you have a default case, and then at the end you have a value that's set to something that you want. But when you wrote this code, what you're actually thinking is something like this, which is what switch expressions introduced. So now you've got the nice lambda symbol, which is, by lambda I mean Java lambdas, the dash greater than symbol. And you can take an enumerator. You don't have to have a default case. You don't have to have a break, because you've covered all the cases here. And if you don't cover all the cases of the enumerator, then you throw an exception. And you can see when you wrote this code, you were actually thinking about this, and it makes it much more simple and much more readable, and much less error-prone. There's way less places for bugs to hide in this code. If you forget a break in the previous code, who knows what's going to happen? So these are small things that we continue to bring to market to make the language more simple but powerful. Records is something that's still, I believe, in early access. I'm actually not totally sure. I think early access today, but it's not available just yet. You can try it in an early access build of Java and the JDK. This is a very, very typical class as a Java developer. It's basically just a place to hold data. There's nothing special about it. You've got getters and setters. You've got toString equals and hash code. You've got a compare method. These are just things that you implement in extend object, and you've got a place to store data. You don't really need 100 of these if you have 100 things you want to hold data buckets in. What records does is turns this code, which is actually much longer than probably this, into this. And now you've got something which is very, very powerful. In fact, you can extend this to bring more kind of custom functions into there. You do give up some functionality of like your traditional Java object, but you get simplicity if you are sort of want to work within those constraints. So that's what Records brings to the language, and that's coming out, hopefully, I don't think in Java 14, but I would imagine that shortly after, it will be ready for early access. 5 minutes, is that what that means? Excellent. Okay, let's cruise along here. Perception of modernity. Now, I said I would talk a little bit about Java history, and hopefully this has been semi-educational for you if you know any Java developers, you work in an organization that has Java. But there's a particular reason why Java is looked at as slow-moving, because in a way, it has felt very slow. If you look at Java 1, which came out in 97, 5, and then you fast forward to Java 9, which was 2017, look at the red, if you can read that. The idea was every 2 years to come out with a new version. And in 1995, when you had waterfall methods, and that's kind of how software was shipped, every 2 years made sense. But then look at Java 7, 8, and 9. 5 years, 3 years, 3 years. It took literally 11 years between 2 versions of Java to produce new code for developers to use inside their applications. There are a bunch of reasons for this. The acquisition of Sun was one reason, blah, 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 blah. Lambdas took a long time to get right, so they actually delayed it by a year, and there's a reason that Lambdas looks very natural today, because it took a long time to deliver. However, this model no longer works anymore to get new features in the hands of developers. Now let's look at Java 9, 10, 11, 12, 13, and soon to be 14. 6 months. The release cadence of Java has changed so that it is time-bound now, forcing every 6 months a new version to come out. So what's in the JDK, or what's in that version, will ship. What's not ready gets pushed for 6 more months. But that's OK, because you didn't have to wait 3 to 5 years to get it done, to get it out there. So imagine what happened when you were approaching the deadline and you had to get something into the JDK, and that ship date was coming. You had a small feature that's been sitting behind Lambdas for 3 years. You got to rush it in there. And then people would wait a year anyways to implement that new version. So everything has changed in Java in the past couple years. And then finally, a couple more things. Project Scala is actually moving OpenJDK development into GitHub itself. It's taking all the workflow that used to happen in Mercurial, mailing lists, et cetera, things that a lot of people really, really love, but modeling that in a Git workflow style, and then mirroring that between the traditional workflow of working with mailing lists, et cetera. And that's happening with Project Scala. There's a very heated conversation going on right now in the OpenJDK mailing lists about whether this is the right time to introduce this. If you care, come on, take a look, subscribe to the mailing list for Scala. Finally, 3 last things in the 2 minutes that I have. Ecosystem is incredibly important. Java has a rich ecosystem ready to use for serverless applications. One thing that's really important is interfacing with native code. Native code is really fast because it is native. You're not doing any translating of bytecode into native code and doing compilation at the time. Sometimes you just need to go native to do things like GPUs, to use CUDA or OpenCL, OpenGL, OpenSSL. This is where you want to start to write C++ code. Traditionally, you had to use something called the JNI, or Java Networking Interface. I think that's what it stands for. It is very ugly. In fact, JNI, I'm going to skip it, but there's a bunch of... Yeah, thank you. There's a bunch of oh, hey, what's up? There's a bunch of steps. We eliminate that with Panama so that there's really only one step, and you don't actually have to write C++ to get to work with C++. So take a look at Project Panama if you want. OK, cloud platform support in the 1 minute I have. I think this is mostly accurate. I know some of you probably look at it and go, no, you're not right. Amazon Lambda started in 2014 with Node only. About a year later, it came out with Java support. Still, only Java 8 today, unless you're using custom runtimes. I get it, but that's more complicated. Azure Functions, 2016, C# and Node. Just last year, I believe, they added Java 8 support. 9, 10, 11, 12, 13, 14, not available yet, of course, unless you're using containers or custom runtimes. Some CDS support today, no app CDS if you're not using Java 9 or above. No native JLink. All the language features I talked about are not available. This is one of the reasons that Java is held back. Serverless is, we are not this sort of being able to advance past 5% of the functions because it needs to move faster within platform support. Finally, lighter work frameworks. There's a bunch of interesting ones out there to take a look at. These are kind of more for microservices. But if you take a Helidon, MicroProfile, these are the implementations of MicroProfile. Helidon, Quarkus, Micronaut. There's a couple others to take a look at. But there is a lot of work happening to make Java faster, to make it smaller, to make it work for suitable workloads like machine learning and serverless. So that's my entire talk, only 30 seconds over. Is Java ready for serverless? I pose the question to you. I'd love to have the conversation. And what is your story? If you're using Java, I'd love to hear it in the 1 hour I'm going to be hanging out before I have to catch my flight back home. So thank you very much.